Today we're going to deal with percent change of dimensions. So what happens when we, change length and width or radius, and what does that do to area and perimeter? We've alluded to this a little bit this year. We're going to hit on it some more today. A couple things to remember here is that a dilation, the percentage of the original would be 100% plus the percent of increase. And on a reduction, the percent of the original would be 100% minus the percent of decrease. All right, so let's get into some examples, and you'll see what I mean here. There are two concentric circles on the playground. Here's an example of concentric circles that share the same center. The diameter of the larger circle is 40% greater than the diameter of the smaller circle. The area of the circle, of the larger circle, is what percent greater than the area of the smaller circle. So they don't give us any dimensions other than the fact that they tell us that the diameter of the larger circle is 40% greater than the diameter of the smaller circle. All right. So it's 40% larger, so that means it's 140%. So the scale factor is 1.4. Now since area is a dimension squared, if I just do that scale factor squared, I'll get 1.96. And since 1.96 is 0.96 greater than 1, then the bigger circle has actually got an area that's 96% bigger than the smaller circle. So all I did here is I found the percent, added 40% to the original, turned that into a scale factor by just turning it into a decimal. I squared that because area is square units. And then I got 1.96, and 1.96 is 96% bigger than 100%, the original. Now we can show this a much longer way, and that's what I'm going to do now here. Okay, I can call this original diameter 100, and I can call the new diameter, the larger diameter, I can call that 140. And then what I can do here is find out the area of the smaller circle, which I'm going to call 2,500 pi. I can find the area of the larger circle, which I'm going to call 4,900 pi. So the change here, the larger circle is actually 2,400 pi because percent change is the change divided by the original. The change here is 2,400 pi, the difference between the bigger and the larger. 4,900 minus 2,500 is 2,400 pi. And the original was 2,500 pi, the red circle. And you can see I get 96% change. It's 96% bigger. You know, which way is easier? I'd say this writing in blue is a lot easier, but it does work. Becky reduced the size of an image on the computer screen by 40%. By what percent was the area of the image reduced? Okay, so when they say that she reduced it by 40%, what they mean is they reduced both the length and width by 40%. So we're reducing it by 40%. That means the new image is actually 60% of the old image, which means the scale factor is 0.6. We're talking about area here, so 0.6 squared would be 0.36, and 0.36 is 64% less than 1. So it's 64% smaller than the original. Okay, so one more time here. 40% decrease, that means I've got 60% of the original. I'll turn that into a decimal for the scale factor, and I'll square that because we're dealing with area. I get 0.36. Now the original was 1 squared, which is 1. If we subtract 0.36 from 1, we get 0.64, or 64% smaller. Now we can show this with the drawing here. We could say that the original computer image is, let's say it's 10 by 10. And then we can say the new computer image is 4 by 4. That would be, or I'm sorry, 6 by 6. That would be 40% less. The area of the large would be 100 square units, and the area of the small would be 36 square units. So the difference between them, because percent change is the change divided by the original. It would be 64 for the change divided by 100, which is 64%. And that's the same thing we did with the circles on the previous problem. It's probably a lot easier to understand here with the rectangles than it is with the circles. So we don't have that pi involved, but it's the same thing going on. If a square was dilated 150%, then by what percent would the perimeter increase, and by what percent would the area increase? Okay, if it was dilated 150%, that means the scale factor is 1.5. So the perimeter, it's just a measure of length. That's one dimension. So the perimeter will increase by 1.5, or 150%. I'm sorry. It'll only increase 50% because 1.5 is 0.5 more than 1. Okay, so the scale factor is 1.5. 1.5 is 0.5 more than 1, the original. So it'd be a 50% increase. Now with area, we have to take that scale factor and square it. We get 2.25. 2.25 is 1.25 bigger than 1. So the area is actually will increase by 125%. Okay, so perimeter, you just take the scale factor. That is 50% bigger than the original. Area, you square the scale factor. That's 125% bigger than the original. Suppose the dimensions of a 2-inch cube were increased by 100%. What would be the edge length of the expanded cube, and the volume of the expanded cube would be what percent of the 2-inch cube? Okay, so suppose the dimensions of a 2-inch cube were increased by 100%. So we're increasing by 100%. That means the new percentage is going to be 200%. So the scale factor is 2. So the new edge length, it was 2 centimeters. The scale factor is 2. The new edge length of the expanded cube would be 4 centimeters. So now let's deal with volume here. And the volume of the original is 8. And the volume of the new is 64. So percentage of the 2-inch cube, the volume would be 800% bigger. 800% of the original. Okay, that's all I've got for you today. Definitely rewatch it if necessary, especially that first example. Probably caught a lot of people off guard, but that's the beauty, is that you can rewatch these as many times as you want. Good luck. Come in with your questions tomorrow, and I'll see you then.